Let's go through various data types and some of the variable operations in this video. This is just a few of the existing primitives that you see in C++. You see your appendix 8.2 for literals and subalert values of these data types. Integer. This is a typical 4 bytes that stores integer values. You also have float doubles. The difference between these two floats and doubles and the typical integer is float and double have decimals. We have decimal precisions that can be stored inside float and doubles. Double has up to 14 to 15 decimal numbers, whereas float has half the double, which is about maybe 7 to 8 decimal. You also have long and short types. Long and short types, these are modifiers that can also be used in conjunction with in. So you can have long in, you can have short int. But long and short basically means one is greater than or equal to and the other one is less than or equal to in terms of the memory storage. If integer is 4 bytes, long could be just as big as an integer, but typically double that. In binary system, when you have a number that is bigger than the other, typically it goes into the next 2 to the factor, which is 8. If integer is 4 bytes, short could be 2 bytes. This is another one. Sometimes people pronounce this as char. I like to call it char. Char is short for characters. So this is the most fundamental ASCII characters that you can have for storing a individual or single characters in computer science. If you look at your keyboard right now, there's about 128 different characters on the keyboard. Each of these individual characters is what we call char in C++. And some other language too. You can have capital A to Z or small letter A to Z, 0 to 9. These are all individual characters. And the important thing about this characters is each one is enclosed in a pair of single quotes. This is a single quote. This is the one that next to your return key on the right side of your keyboard. There's also string data type. String is a sequence or a group of characters, basically just one to many characters together. One thing about string is most of the languages, they use double quote to represent it. So if you have a hello world, you see double quote, and that is the entire string. Now, string in C++ is a class. This is actually 24 bytes. The last one is Boolean. In Java, this is Boolean. In C++, we use bool, Bool. In other languages, there are different representation of these namings. By and large, true is 1 in computer science, false is 0. Both true and false are keywords. So you cannot have variable name with these names, true or false. True value is 1. False value is 0. Anything that is not false is true. If you have a value of 23, if you convert it to Boolean, it's actually true. These are very popular set of primitives that you want to commit to your memory if you can. Most of the time, we use float double, integer, char, string, and Booleans. We don't really touch long and short unless you get into scientific computations. The definition of primitives means that it is native, that you don't have to invoke any other libraries to make use of them. A variable must be declared before usage because you want to commit some memories to it. If you don't declare a variable by way of using its type, the computer is not going to know how much memory it needs to store this information in memory, to hold this information in memory for you. Great is the name of that stake on the ground. This integer is 4 bytes. This is very important. If this stake on the ground does not have a allocated memory space, you will not be able to use it. At runtime, it is important to assign values to it. Without this assignment, you could have a whole bunch of ones and zeros in that space. You will connote to a value. Sometimes it may connote to another string, something like this. So you don't want to simply just leave your variables untouched, uninitialized. The best way to go about this is every time you declare a variable, you want to initialize it. There should be some default value associated with this variable. Every declarations and assignment, even this print statement here that prints this thing to the console plus a new line, they all have to end with a semicolon. A semicolon means the end of line of code. Here's another part about initializations. You can have them all inline like this, or you can do it separately. You can actually chain them. This could be pretty long. This helps so that you don't have to keep writing integer length, integer width, integer areas, and so on and so forth. Only 2 variables are initialized, and the other one uninitialized. Quickly, The assignment calls for equal sign. The equal operator simply means to store information into this variable that you just declared. The assumption is that this name of students has been declared somewhere above this line already. You can't do this. Assignment says your variable has to be on the left side, and the value you wish to assign into that variable has to be on the right side. So this is an error, compilation error. You won't be able to proceed. You probably hear something like literals in computer science. So literal means constant. So if this is a literal that is applied to a number, then this is what we call numeric literal. So numeric literal could be a double, could be a float, could also be an integer in this case. You can also have non-numeric literals like your string, hello world. This is a string literal. We have integer literal that is assigned to this grade variable. This is part of the initialization. It is important to know what literal is in this sense. You can also have double literal, string literal, so on and so forth. A variable stores information, and that storage happens in memory. Memory has a whole bunch of ones and zeros, and in fact, variable has to be declared. Grade is assigned a initialized value of 60. So this one should be a CN. So that way you can have this value inserted into grade. Let's just talk about this brand new concept. It's called variable scope. A variable could be declared either outside of your main or inside, or sometimes you can have methods or functions as well in your code. Depends on where the variable is declared. If it is declared inside this main is what we call a function. In a console application, it's what we call function. This grade, this variable has what's called this main scope, meaning when you exit, your flow of control exits your main. Return 0 basically sends your entire instructions back into your execution unit. Your execution unit is CPU. CPU looks at it and said, this assembly code is asking me to return this to 0, meaning shutting this entire program down. Then your scope for that variable is gone. Inside this main function, this variable grade has what we call local scope. You can actually lift this entire integer grade outside of the main. That grade variable will have what we call global scope. Anybody inside or outside of this main will be able to be able to make use of this grade variable, making it modifiable by anyone. Sometimes that can cause issues. Later on, we're going to go through function scope. We're going to go through various different program scope where you can actually assign various different block scope in code. Variables can be declared either within or outside of it. This actually allows you to kind of control section of your code to have certain behaviors driven by these data variables. This allows you to kind of set scopes on these variables where they can only be used within a particular local scope that you define.